Hello everyone, welcome to iitiansgateclasses. So in this session, we'll be discussing about Gate 20, Gate 2007 and 2008 mechanical vibration part solution from Gate Aerospace Engineering. So those who are watching this session can respond in chat. Am I audible? Quickly, guys, respond in chat. So let's start. 2007 Gate Aerospace Engineering paper. So there are total six number of question in Gate 2007 when there were 85 questions were asked in Gate exam. That is the old pattern. From 2009 onward, they are asking only 65 question. So weightage has been reduced. So there are total six question which is for mm, 10 marks. Okay, so for 2 marks question and one is two is for 1 mark questions. So we will see this first question. What is asked in this question, guys? A spring mass damper system. A spring mass damper system. A spring mass damper system with a mass of 1 kg is found to have a damping ratio of 0.2 and a natural frequency of 5 radian per second. The damping of the system is given by. So this question is from damped free vibration. So guys, can you try? So what is given? Damping ratio. So damping ratio is denoted by zeta and it is given as 0.2. And we know damping ratio is what? It is damping of the system upon critical damping coefficient. So it is C by Cc. Now what is asked? They ask C and we know what is Cc. Cc is usually it is 2 under root Km. 2 under root k m or 2m omega n. So this is also written as C by 2m omega n. Okay, clear? Now guys, here what is given? Zeta is given, m is given, omega n is given. So what is C? The damping of the system, it will be 2m zeta omega n. Now substitute everything. M is given as 1 kg, zeta is zero point 0.2 and omega n is given in radian per second. So it is 5. Okay. So what you guys get? It is 2 Newton second per meter. So now guys, one thing you guys have to make sure the unit should be correct. There are two options where the answer is 2, A and B. Now which is correct? Is it correct A or B? Which is correct? Sahil, Harsha? The correct answer is A. Now, how we can check whatever we have done is correct or not? So we can check by simple way. How? We know, guys, the force due to damping is always given by what? F equal to Cx dot. Okay. Now, guys, C. So what is the unit of C? It will be Newton divided by meter per second. X dot is what? Velocity. So what is the unit? It is Newton second per meter. Clear? Clear everyone? So A is the correct answer. Let's move to next question in gate 2007. Yeah. So question number 6. The number of natural frequencies of an elastic beam with cantilever boundary condition is? So first, guys, what is a cantilever beam? A cantilever beam is fixed at one end and free at another end, and it comes under what? The vibration of cantilever beams comes under the category of what? Continuous system. And we know for any continuous system, the degrees of freedoms are infinite and the natural frequencies are infinite. Why? Suppose this cantilever is vibrating in vertical plane. So you can see at every section there is a particular displacement. Okay, so you need infinite degrees of freedom, okay, to define this system, and there will be infinite natural frequencies corresponding. So the answer is, what is the answer? This question is from continuous system and the answer is D is the answer. Clear? Sai, Larsa, is it clear? Others? Now let's move to next question. Question number 23. Here, this is one of the good question, and many people find difficulty in this question. So I'll explain how to deal with this question. Read the question what it says. A 1 kg mass attached to a spring elongates it by 16 mm. The mass is then pulled from its equilibrium position by 10 mm and released from rest. Assuming the acceleration due to gravity is given this, the response of the mass in mm is given by. So guys, this is like simple spring mass system. So it's a case of what? Undamped free vibration. Okay. Now see, this is spring mass system. Suppose K is the stiffness and M is this mass. So we know the natural frequency for a simple spring mass system is given by what? Omega n is given by under root K by M, or it is also given by what? Under root G by delta static. Delta static. Now guys, in this question, they gave G value which is 9.81, and they also gave delta static, like when spring is freely hanging, so there will be some permanent deformation, okay, and that will be balanced by what? Gravity. So we always know, right, mg is equal to what? It is equal to what? K delta static. So from there we find natural frequency is also given in terms of delta static. Now what is the delta static? They told the spring elongate it by 16 mm, so it is given as 16 mm. So guys, when you find natural frequency, first you make sure you convert this 16 mm in meter, because G is in SI unit. It is meter per second square. So it is what? 10 to the power minus 3 meter. Now first find out omega n, guys. Find out omega n quickly. How much is the omega n? Sahil, how much is omega n? So it is what? It is under root 9.81 upon 16 into 10 to the power minus 3. So it will be coming how much? It will coming as 24.76. Okay, and the unit will be radian per second. Correct. Now once you know omega n, now the people have confusion ki the response should be either sinusoidal or cosine. So guys, whenever you take case of free vibration, you can start either with sinusoidal solution or you can start with quasi. But the final solution will depends on the given initial condition. So what is the initial condition they have given? They told the mass is released from rest. The mass is released from rest. And what is the initial displacement they gave? 10 mm. So what is your initial condition, guys? What is your initial condition? Whenever, anywhere it is written, the mass is displaced from rest. What it mean, Mr. Harsha? What it mean? What will be the initial velocity sign? When it is told, if system is released from rest, what will be initial velocity? Anyone? What will be initial? The initial velocity will be 0. Okay, so v naught is 0, or you not v naught, v is 0, or you can say x naught is 0. Okay, now what is the second boundary condition? They told the initial displacement x at t equal to 0 is how much? 10 mm, and this is also what? At t equal to 0. Now guys, if you take, let's take initially x is my solution and it is given by what? Amplitude x sine omega t, okay, plus some phase angle phi. This is how my solution is given. Okay, now guys, if this is your solution, then what first condition is there? The first condition is what? At t equal to 0, your velocity is 0, right? At t equal to 0, your velocity is 0. Okay, so how you find from this solution velocity? Velocity is given by what? X dot, right? So x dot is nothing but dx by dt. So what it will be? It will be the differentiation of sine is cos, right? So your x dot will be what? X, capital X, which is amplitude of vibration. So capital X omega cos of omega t plus phi, right? Now guys, you got this clear, everyone? Now here you substitute at t equal to 0. What is your x dot? It is 0. So 0 equal to capital X omega, which is your natural frequency. You can write it as omega n, omega n, and omega n, right? Now capital X omega n. Now cos of t is 0, right? Cos of phi, right? Now guys, this capital X can't be 0. So what has to be 0? Cos phi need to be 0, right? When cos is 0, anybody? When cos is 0? When cos is 0? Anybody? Cos is 0 when cos 90, right? Am I correct? So cos 90 equal to what? Cos of phi. So from here, what is your phi? Phi is coming as 90 degree. Clear? So when phi is 90 degree, you substitute in this equation. What will be your solution? In case of when initial velocity is 0, your x will be capital X sine 90 plus theta is what? Cos theta, right? So it is capital X cos of omega n t is your solution, right? Now guys, here they already told at Another boundary condition is what? Not boundary condition. Another initial condition is what? It says at t equal to 0, your x is what? 10 mm, right? So then substitute in solution 10 equal to capital X cos of 0. So what is your amplitude? Capital X. What is your amplitude? Sine, it is 10. So what will be final solution for this given case of vibration? It will be 10 cos of omega n is how much? It is 24.76 t. Clear now? Why A is not correct? Clear everyone? Yes or no? B is the correct answer. We have assumed the solution as sinusoidal, but for given initial condition, the solution will be cosine. What it means? If you draw your solution diagram, it will look like this. You guys can see it will be at t equal to 0, you have initial displacement x naught, which is what? Amplitude of the vibration, and it's a case of free vibration, so there will be no amplitude decay. Now you guys can observe this function is what? Cosine or sine? Mr. Sine, it's a cosine or sinusoidal function, or plot of cosine or sinusoidal function? It's a cosine, right? Right, so that's why the answer is not A, it's a B. Now one more check we can do. What check we can do? This is what your answer, right? Now guys, when you substitute in this equation t equal to 0, what displacement you should get, guys? What displacement you should get at t equal to 0? 0 or non-zero? It should be 10 mm, right? It should be 10 mm and it should be non-zero. So if you substitute t equal to 0 in this equation, you will get x equal to 10 mm, which is what your given condition. Same time, if you differentiate this, you will get velocity x dot. What will be velocity? You will get 10 into 24.76. Differentiation of cos will be minus, so it will be minus sine 24.76 t. Now again you can check, if you substitute t equal to 0, what will be velocity? 0 or non-zero? 0 or non-zero? So you can check, it will come to be 0, and which is what? Your given initial conditions. Okay, so let's move to next question. What it says? A spring mass damper system is excited by a force F naught sine omega t. The amplitude at resonance is measured to be 1 centimeter. At half the resonant frequency, the amplitude is zero point 0.5 centimeter. The damping ratio of the system is. So this question is from forced vibration. And we know in case of forced vibration, guys, your the solution of the system will have two components. One will be steady state and another will be transient part, right? So here they have given amplitude at resonance, which is what? For steady state part. Okay, so we know, guys, the amplitude of steady state response in the case of forced vibration is given by what? It is given by what? Amplitude of the vibration, your x, in case of what? Steady state response is given by what? F naught by k upon under root of 1 minus omega by omega n square whole square plus 2 zeta omega by omega n whole square. So this is how the amplitude of steady state response is given. Now they have already mentioned this amplitude x at resonance. Resonance means what? At resonance, your omega is omega n. Okay, your omega is omega n. So your amplitude x1, which is at resonance, will become what? F naught by k upon 2 zeta. Okay, and it is given as what? 1 centimeter. Now guys, what further they told, at the half of the resonance frequency, at half of the resonance frequency means at omega equal to omega n by 2, what is your amplitude? What is your amplitude, guys? They given it as a zero point 0.5 centimeter. Okay, it is given as 0.5 centimeter, means your x2, which is what? Again it is f naught by k upon under root 1 minus, now guys I will substitute omega. Omega is here what? Omega n by 2 upon omega n whole square plus 2 zeta omega by omega n. So it is again omega n by 2 omega n whole square, and this is given as how much? 0.5 centimeter. Now guys, if you take the ratio of x1 by x2, if you take the ratio of x1 by x2, what do you get? What you guys get from here? You get it as what? 1 by zero point 0.5. Okay, and this is equal to what? This will be equal to, if you substitute, this will get cancelled, and again this will get cancelled, 2 get cancelled. So what you get? You get 1 by 4. So you get 8 under root 9 by 16 plus zeta square upon 2 zeta. Now guys, from here, what is unknown? Zeta. So guys, calculate, simplify it and find out zeta value. So how much we will get? 4 zeta square will be equal to what? 9 by 16 plus zeta square. So you can say it is 16 zeta square, means 15 zeta square equal to 9 by 16. So from here, zeta will be what? Under root of 9 by 15 into 16. Anybody? Just find out this, how much the value. So this kind of question, I think they asked one more time, where they have given amplitude of steady state response, and then they ask some unknown quantity. So this is how we need to deal with the question of forced vibration. So 0.194, let me check. Yes, correct answer. Yes, that's correct. So the answer will be 0.194. Now, one thing I want to highlight here. What we learned from this question, Mr. Sahil, Harsha. See, we tried to reach till last step. Then only we did calculation. Clear? We try to simplify as much and then only do calculation. Don't do calculation in between. Okay? So it is always easy to find, the square root of 9 by, we can even multiply 16 into 15 also, we can multiply and then we find square root. So that is what you need to, take care during exam. Let's move to next question. What it says? Yeah. So here what they told, consider the spring mass system shown in the figure below. This system has 2 degrees of freedom representing the motion of two masses. So this question, any issue with the question? Yeah, here there is a typo. Yeah, I got Sahil. I got here, I have done one typo. What is the typo? This is not there. No, no, correct, na? Not typo. What is the issue? No, 16, then 1 you have to subtract, na? So it will become 15, right? So 15 zeta square equal to 9 by 16. Is it correct, right? There is no typo. Shail, can you confirm this is correct, right? Anybody can confirm this is correct or not? Yeah, okay, thank you. So let's move quickly to this question. What it says, these two masses are connected like this, and they ask, the system shows the following types following type of coordinate coupling. So guys, in last session, one of the session also, we have done this question. So guys, first understand what is the coupling. So there can be two kind of coupling. One is a static coupling and one is the dynamic coupling in a mechanical system, or there can be a combined coupling also. So the generalized equation is given by what? Mx double dot plus cx dot plus kx equal to 0. This is the equation of motion. Okay, equation of motion for vibration of damped free vibration. Okay, so usually if you have multi degree of vibration, so it will be M matrix X double dot plus this will be C matrix if there is a damping, and this is K matrix due to stiffness, and this is equal to 0. Now for 2 degree of freedom system, this M matrix is written as what? M11, M12, M21, M22. Okay, and this will be what? X1 double dot, then X2 double dot. Then this C matrix is again what? C11, C12, C21, C22. Then it is what? X1 dot, X2 dot plus K11, K12, then K21 and K22, and it is X1, X2. This is equal to 0. So this is what your equation of motion. Now in this case, if you look, when you will have dynamic coupling, if when you will have dynamic coupling, if in given system in equation, if M I not equal to j term, I not equal to j term is non-zero, or c I not equal to j terms is non-zero. Okay, so in M matrix, if Mi not equal to J term is non-zero and Ci not equal to J term is non-zero, then the system will be dynamically coupled. Okay, now when the system will be statically coupled, just a moment. So when the system is statically coupled, if in your K matrix Ki not equal to J term is non-zero, then system is what? Statically coupled. Okay, so this is about coupling. Now if you check your given system and if you try to find your equation of motion, then you will see your mass matrix is not coupled. Anyway, C matrix is 0 because there is no damping, and your K matrix will be coupled. K matrix will be coupled. Means your Ki not equal to J terms will be non-zero. How we see? So if you try to write the equation of motion for this given system. So how it is given? This is the K matrix. Sorry, stiffness. Then this mass M. Then again spring, and this is 3m, and this is K. I think stiffness of each spring is given as K. Yes. Okay. So M, this is K. Now this is the x1 displacement, and here it is applied x2 displacement. Now, if you try, first see the free body of this mass, and we are considering if x1 is greater than x2. So what all the forces it will have here? It will having kx1. Then inertia force, it will be what? M x1 double dot. And then in this spring, if x1 is greater than x2, so what is going to happen? If x1 is greater than x2, then this will get compressed. So that means there will be opposite force, which will be what? It will be k x1 minus x2. So there is no any other force on this mass, which is M. So what will be equation? It will be M x1 double dot, then plus k. Now I can take x terms together, so it is what? It is 2k x1 minus k x2 is equal to 0. Okay, now for mass 3m, so if you write for mass 3m free body from Newton's method, what you see, this mass is moving in this direction with x2 displacement. So this spring will get compressed, so there will be opposite force, which will be what? Kx2. Now there will be opposite force in the opposite to direction of motion, so it will be inertia 3m x2 double dot. Now this force is in this direction, so there will be opposite force, okay, due to this middle spring. So what is that opposite force? It is k x1 minus x2. So what will be equation of motion for 3m mass? It is 3m x2 double dot. Then we can write this kx2 term and this. So you can see this is kx2, then this force is in opposite direction, you can see here, so it is minus k x1 minus x2. This is equal to 0. So again, if you write it, what you will see, 3m x2 double dot, then you'll get minus k x1, then plus 2k x2 equal to 0. Now if you write these two equations, this is first and this in matrix form, how it will be written? If you write in matrix form, if you write these two equation in matrix form, what you see, your mass matrix will be given by what? It will be m003m. So you can see there is m I not equal to j terms are 0 in this. You can see in this matrix I not equal to j terms are 0. So it is not dynamically coupled. If you see static k matrix, so what will be your k matrix? It is what? 2k minus k, then minus k, and then 2k. So you can see in k matrix, k I not equal to j terms are non-zero. So it is statically coupled. Clear everyone? Is it clear? Yes or no? What is the answer for this? Everybody, what is the answer? Child, is it clear? Harsha and others, those who are watching this session, if this session is useful, can thumbs up. Okay, so the answer is A, the system is statically coupled. Now, the second part of this question, if you see what they asked, in the second question, they asked natural frequency. So, consider the spring mass system shown in the figure. Already, this system has 2 degrees of freedom representing the motion of two masses. They asked the two natural frequency of the system is given by. So for 2 degree of freedom system, what is the equation of frequency? It is given by what? m1 into m2 omega power 4 minus m1 into k2 plus k3, then m2 into k1 plus k2. This is multiplied by what? The whole equation multiplied by omega square, then k1 k2 plus k2 k3 plus k3 k1 equal to 0. This is what? The frequency equation for 2 degrees of freedom system. Now in this case, we know the k1 is given as k2 is given as k3, and this is what? K. And what is your m1? It is m. And what is your m2? It is 3m. Now substitute everything in this equation. What we see? We see 3m square omega power 4 minus, we see what? 2k into m, 2km, and then 2k into 3m. So you will get, I believe, 8km omega square and then plus 3k square equal to 0. Now guys, using Dharacharya's formula, quadratic equation solution, what you find? Your omega square will be what? It is minus b plus minus under root b square minus 4ac by 2a. So minus b. Minus b means what? B is 8 km and it is what? Minus, right? So minus minus becomes plus. So it is what? 8 km, okay, plus minus b square. So it is what? 64 k square m square minus 4ac. So what is the a? A is 3m square. What is c? It is 3k square upon 2a. So what is a? Again 2. 2 into a. So it will become 6 m square. Okay, now if you further simplify, throughout you can take 2 common. You can also 1 m you can take common, right? So what we find, 3 into 3 9 for the 36, so 64 minus 36 it will be 28. Then again you take 4 throughout, 2 out, right? So what you get, you will get 4k plus minus under root 7k upon 3m is equal to what? Omega square, right? Now from here, what will be your omega, which is natural frequency? It will be under root of 4 plus minus under root 7 by 3, and then you can write k by m. Is it correct? Yes or no, guys? Please check this solution is correct or not. Yeah. So what will be the answer among these? What is the answer? So C is the answer. C is the answer. Okay. So fine then. Let's move to, so done with 2007. Now quickly we will see the question from 2008. So yeah. So GATE 2008, Aerospace Engineering, Mechanical Vibration part. So let's see how many questions. So total 3 questions, and those 3 questions are asked for 5 marks. So two marks question and one mark question. Clear, guys? Let me see what is the issue. Slide is not visible. So read this question, guys. So, guys, just a moment. Wait. There is a small. You read, guys, and solve this question quickly. So is it visible now? Is the question visible now? Perfect, right? Yes or no? So what is the answer? Okay, so let's see what question says. In a spring, in a in a spring mass damper single degree of freedom system, the mass is 2 kg and the undamped natural frequency is 20 hertz. The critical damping constant of the system is. So guys, we again know the critical damping constant Cc is given by what? It is given by what? 2 omega 2m omega n, or it is given as what? 2 under root km. Now in this given question, what is given? The mass is given and natural frequency is given. But the natural frequency is given in hertz. So we need to first convert this from hertz to what? Radian. So when you convert hertz to radian, you need to multiply by 2 pi. So everything is given. 2, what is the mass? It is 2 kg. What is omega n? It will be 2 pi f. Okay, what is the frequency is given in hertz? It is 20. So now tell me the answer. How much? 2 to the 4, 4 to the 8, 8 to the 16. So what can be the answer? Only one answer is possible. Anybody? A is the answer, right? It is 160 pi Newton second per meter. Okay, clear? So it was very easy question. Now, good guys. Next question. Read question number 68. Question number 68. What it says? An engineer is asked to test a system which can be idealized as single degree of freedom with viscous damping. A frequency response test was conducted and it is found that the quality factor Q is equal to 10. What will be the logarithmic decrement if a free vibration test is performed? So guys, first what we should know, what is quality factor? So the quality factor is nothing but magnification factor at resonance. So the quality factor Q is given in viscous damping in case of damped free vibration. How it is given? Quality factor is given as 1 upon 2 zeta. Okay, now what is the Q value? They given 10. So from here we can find what? Zeta. So what will be zeta? It will be 1 upon 20. 1 upon 20. Once you know zeta, we know what is the logarithmic decay. The logarithmic decay, what the logarithmic decay delta in terms of zeta, how it is given as 2 pi zeta upon under root 1 minus zeta square, or approximately it is nothing but 2 pi zeta. Okay, now guys, zeta value is given. What will be your delta? It will be 2 pi upon 20. Okay, so guys, find out the answer. What is the answer? It is pi by 10. So look into option and tell me the answer. So what is the answer? C is the answer. C is the answer, right? So let's move to next question. What it says, that is the last question for today. Okay, read the question. What it says: the equation of motion of a uniform slender beam of length L in flexural vibration is given as this equation. So this is what governing differential equation for vibration of beam, where EI is flexural rigidity, W is lateral displacement, rho A is the mass per unit length. The beam is simply supported at the two ends at x equal to 0 and at x equal to L. Assuming the mode shape in fundamental mode to be sine pi x by L, the natural frequency in fundamental mode is. So guys, we know this sine pi by L x is nothing but what? Sine kx. So from here, if you compare sine kx equal to sine pi by Lx, okay, in case of vibration of beam with simply supported. So what is the k value we are getting? K we are getting pi by L. And what is the k in case of vibration of vibration of beam? So what is the k? The k is given by what? Under root omega by c. Okay, so here it is what? Under root omega n by c. This is better way to write. Okay, so here under root omega n by c equal to what? Pi by L. What is omega n? It's a natural frequency. So what is omega n? It will be pi square by L square into c. Now what is the c? The c is given as what? Velocity of wave propagation, and it is given by what? Under root ei by rho a. So what will be the final natural frequency? Pi square by L square under root ei by rho a, or you can write it as what? You can write it as what? Under root ei by rho a L power 4 into pi square. So what is the correct answer? Swastik, what is the correct answer? So how I came to know? This is what my displacement part of final solution of continuous vibration of beam. It is from basics of science. So you guys can refer vibration of continuous system, and the best part, if you want in a simple word, you can refer Grover book, mechanical vibration Grover. Okay, so B is the correct answer. So that's all guys for today's, and in next session we will be discussing gate 2009 to 2011. Okay, and tomorrow will be the next session. So if you guys have any query, you guys can reach to IGC contact number for any course related to gate aerospace engineering. Okay, so it is 9740501604, and our upcoming batch for gate 2025 is starting from Feb 18th. And if you felt this session was useful, can like our session and can share with your friends. And also you guys can follow us on different social media platforms. You guys can join our Telegram groups for more updates like jobs or anything else. Yeah. So that's all from today's session. So thank you all. And one more update, guys. Today's next session is for aircraft stability and aircraft performance part of 2009 flight mechanics session from 9:30 onwards. Thank you all.